everyone, how are you all? Myself Pranshi and welcome back to my YouTube channel, and in this video we will be learning about limits and continuity. In the previous session we already learned about what is function, function type, function family, and what is the significance of function in calculus. Limits are very you can say it's a foundational block of the differentiation and integrals, so we have to take this session very seriously. So without wasting any minute, let's get started. Let's understand with the example. And I need a smartphone. Okay, my smartphone at a particular distance from me. Example 10 meter. Now it's a 5 meter, 3 meter, 2 meter. Okay, so what is the path? It's a journey. Okay, this is my function. Okay, and this is my destination of a function, the result. This path, this journey of my smartphone distance towards me is called limit. So limits are, what is the limits in the language of calculus is how when we used to talk about behavior near a point, not just at, we are talking about the whole journey of a point. We are not talking about the starting point and end point, which means question and answer. We are talking about its whole journey. It's the path, its behavior by following that particular rule. So this is what limit is all about. Okay, so let's understand it with a more good way. So what is basically the limit? Limit is basically the journey. Okay, let's understand it with the journey. How we demonstrate limit, how we write limit. LIM x tends to 2. Now this is fx. Now what is fx is? Okay, as we already learned about fx, it is a function. Okay, this is a function, and x tends to 2 means function have to reach to 2. Okay, let's understand with another example what does this thing means. What is this thing means? Okay, fx is our function. It is some set of a rule, and then we set the limits tend to go to 2. Now limits tend to go to 2, so which means we are finding its result when the point, the journey limit is starting from 2.1, 2.2, 1.9, 1.8, the nearest point. We are talking in the limits, we are talking about its nearest point. We are not just talking about, we don't care about the result in limits, we take care about its whole journey. For example, this is why the limits are important. You are launching a space shuttle, and with even in the slightest change in the direction and a particular time, even in the slightest change in the direction and minimum change in the time, it can divert into different galaxy. Okay, it will divert into different direction. Our space capsule will get lost. So this is a part why we really need to talk about the journey, because in the journey, in the limit, in the word of a calculus, the limit is defining the journey. It is defining about the nearest point of our solution. So we take care of that, and we are solving our equations, we are solving our problems with considerate with its nearest point, with consideration of its nearest point. That's why we use limits. Okay, that's why we use limit. Let's solve one of the question on limits. Let's take my favorite color, yellow. Okay, let's solve the question. Our limits tends to go to 2, and this is our function x to 3x plus 4. Now when you see such type of question, how to solve it? By direct substitution. By direct substitution. Let's put x equals to this. So what is 2 square plus 3 2 plus 4 equals to 4, 3 2 is 6 plus 4, 4 4 8 equals to 8 plus 6 equals to 14. So our answer is 14. Okay. Now there is a second question. Whenever you see question like that, okay, limit x tends to 1, x2 minus 1 and x minus 1. So if we try to do it by direct substitution, then the answer would be like 1 minus 1, 1 minus 1, which is equals to 0, which is not possible. When we are solving a question by limit, our main idea is we don't want to get 0 as a solution. So we tried our best to not get 0 as a solution. So what we're gonna do, whenever you see such type of situation where direct substitution is giving us 0, which means undefined, so we use factoring. We use factoring whenever you use such thing like that. So there is a formula for this, which is x, okay, which is x minus 1, x plus 1 and x minus 1. So this and this will cancel out. It will give us x plus 1. Now let's put direct substitution where x equals to 1. 1 plus 1 equals to 2. So this is our solution. So till now we have talking about what is limit. Limit is a journey of our whole solution or behavior. We are talking about the behavior. Then we solve how the limit will be solved. Like this is some sort of questions where the limit is taking part in, and we solve two types of methods in the limit, by direct substitution and by the factoring. Now let's put some of the rules. Okay, some basic rules while we solving. While you solve the limits question, just remember the following rule. If limit x tends to 0, whenever you see sin x, then the solution would be 0. It's a direct solution would be 0. Whenever you see limit x tends to 0, cos x, which is equals to 1. Let's remember this is a rule. Okay, whenever you see limit x tends to 0, sin x, x, which is equals to also 1. So these are some of the rules while we solving the questions of limit. Just remember that whenever you see such type of equation, directly put the number. Okay, because these are something important. Limit x tends to 0, ex minus 1 upon x, which is equals to 1. These are the some sort of rules. Okay, let's get back to our material. We understand what is limit is, how we write limit is, we solve its quotients in the limit is. Now these are the two kind of a limit. Okay, if the equation, for example, whenever you see something like this, limit x tends to 0 and this is the limit. The limit does not, for this equation, limit does not exist. For such type of equation, limit does not exist, but we have witnessed, like in the future or whenever you saw such kind of a questions, you have witnessed different type of questions, but we don't know if the limit exists or not. So there are the particularly one rule which is very valid. LHS equals to RHS. We define if its solution exists, if the limit exists or not. So this is our scale. If you have any ruler or scale in your house, just bring it so you understand it better. It starts from 0. Now 1, 2, 3. Okay, let's put it minus 1, minus 2. Okay, so these are the two. We take care about this mini points. Okay, if the right hand side, this is our RHS equals to positive, this is equals to negative. Okay, this is equals to negative. When LHS equals to RHS, which means limit exists. Which means limit exists. Now let's solve it by another example. We have limit where x tends to 2, x plus 3. Now we have 2. So we have 2 in a scale. So what are the let's put it RHS. Okay, let's take a first make a table RHS and LHS. 2's RHS, the most right hand side number of a 2 is 2.1, 2.2, 2.3, and most LHS is 1.9, 1.8 and 1.7. Now we put these numbers, when we put LHS and RHS number in it, let's see what will be the solution. Okay, let's see what will be the solution. 1.9 plus 3 equals to 4.9, which is closer to 5, which is closer to 5. Our real significance is it should be 5, so it is closer to 5. Now let's put 0.8, so it should be 4.8, 4.7. And RHS, it should be 5.1, 5.2 and 5.3. Now 4.9, 4.8, 4.7, 5.1, 5.2, 5.3 are closer to 5. We are looking in the limit, we are looking to the closer points. Okay, so it is a closer to 5, which means limit exists. When there is a number, instead if 4.9, there is a number like 1.2, 1.3 and 4.1, which is a not closer, it is a far away, so that means limit does not exist. Okay, so these are the significance rule to find out if the limit exists or not. Okay, now we understand that how the evaluating limit means. So till now we have solved so many questions of limits. Now the main codes of derivatives, like we're gonna understand derivative in the next session. So before understanding that, we must know what is continuity and discontinuity of a function. Understand with the most simplest manner in the okay. in the continuity, if you have to find if the function is a continuous or not, there are the two rules. Okay, first its limit should exist. First, its limit should exist, and second, function should be finite. Function should be finite, and the both value should be equal. Its function value and limit value should be equal. So let's understand. We have a function called 3. Okay, let's put a function called 3, and we have to solve this equation. Okay, let's say different. Okay. Let's understand with the solution. We have a function fx equals to x2 plus 1, simplest, and x equals to 3. Now 9 plus 1 equals to 10. Now at the same time, limit of x should be 3, and we have to solve x2 plus 1. So in the limit, the solution would be same because it is solving by the direct substitution. So it is also 10. If the function and limit value is equal, then the function is continuous. And how we gonna define why the continuous is very important, because when we're gonna learn the derivative define the rate of change of a function, then the finding the continuity of the function is very important. And